Hi there. Let's learn about collections in Python. It's a quick overview. So in this video, I'll tell you the 3 fundamental categories of collections in Python and what are they used for, best practices on using them. First of all, as you see on the screen that I shared with my Jupyter notebook, there are 3 fundamental types of collections. We call them as sequence, set, and maps. Now, what exactly is a sequence? What exactly is a set? What is a map? We'll learn that. Now, sequences are ordered collections. When I say ordered, they maintain elements in the same order that you create them. Let's take a very layman's analogy of what a sequence collection is. To explain this, I just have a bunch of markers with me. So I'm just going to demonstrate that here. Just a minute. All right. So let's assume that you give me one whiteboard marker at a time, and I want to hold them in my hand as a collection. So you give me the black marker. I'm holding them. Then you give me another marker which is blue in color. That happens to be the second marker you gave me. So I'm holding them again. You can see that I'm holding elements in the order. Let me just make it look good. Okay. And you give me the next marker is red. And then you give me the green marker. As you can see, in what order the markers were given, I'm holding them in the same order. Therefore, there's a consensus between you and me in the element ordering. So you can ask me, give me the first marker. The Python syntax for that would be markers of 0. I'll type the code off in a while. My hands are too tied up now. So if all you ask me markers of 0, I will represent the first marker, which is this here, right? The black. Or if you ask me which is the second marker, maybe I will say not second, but I'll say markers of 2. Index 2 is actually the third marker, 0, 1, 2, right? Which means I will now give you the reference to this red marker. You can also ask me for the last marker. For that, you can say markers of -1. That's a Python syntax, a shorthand way to access elements from the last to the front, especially on sequence collections. And I'll give you the reference to the green marker. So there is a consensus between the programmer and the program about the element ordering, and that's exactly what sequences are. If you have used list or tuple or even a string in Python, they're all sequence collections. We'll go a little more deeper into sequences in due course of time. But now if I ask you what is a set is also a collection. A set is also a collection. Now, how would a set be represented? A layman's analogy again. Let's say you give me the markers one by one this time, and I'm going to just hold them in my hand very conveniently. Just convenient to hold it like this for me, but I will not maintain anything about the order. So you give me the green marker first, then you give me the red marker, then you give me the blue marker, then you give me the black marker. Now when the markers are given to me, I'm holding them as a bunch of markers here. This also is a collection, as you can see. But then there is no ordering. I have forgotten right now what is the first marker you gave me. So if you ask me to start enumerating all these markers, iterate over all these markers and tell me which all markers I have, I first look up the black markers. I find black first, and then I'll say I find red next, and I find blue and green. It is not the same order that you gave me the markers. So in this collection, you cannot ask me for elements based on index. This collection is essentially not subscriptable. You cannot subscript them with square brackets and ask me, give me markers of 0, markers of 2, or markers of -1. But it's still a collection, and such a collection is called as a set. There is one more important thing I should talk about: a set and a list. Now let's assume that this is a list. Oh, I made it straight. Convert it to a list. You can give me one more marker again, and this is black in color. You can see that there are 2 black markers. There is no ambiguity in this collection because I can now ask markers of 0, markers of -1. Though they're both black, they can repeat because the indices are different, right? I can actually place it in this index. Now this time it'll be like markers of 0, markers of 1, markers of 2, 3. This markers of 3. 0, 1, 2. Sorry, 0, 1, 2. 2 markers of 2, right? So you could access elements without any ambiguity, which means sequence collections in general, you could have repeated elements. If you have a list, you could repeat the values in a list multiple times, and that's definitely not a problem in Python. Same goes with a tuple. Same goes with a string. A string can have a lot of repeated characters if you have seen a string, right? But a set, now this becomes ambiguous. This becomes ambiguous. If you ask me, is there a black marker? I find two black markers. Oh, two black markers? This is ambiguous. So you cannot really differentiate one black marker from the other when it's in a set. A set, for that very reason, is treated as a collection of unique items. A collection of unique items. Every item in a set is guaranteed to be unique in Python. How do you guarantee the uniqueness of items? When you're placing every element, the elements are placed based on the element's hash ordering. Well, every element in a set must be hashable. What are hashable objects? These are objects whose checksum, we call them as hash code. Hash code is like a checksum based on its value. Based on the element's value, a unique number is computed. Unique number is computed. That's called the object's hash code. Based on the hash code, an index is decided in an array bucket for holding the items, which means that you cannot have two items stored in the same place. So if there are two black markers, both will end up having the same hash code. Let's call this, let's assume that for each of the marker, the hash code is going to be computed as 20 for green marker, 15 for blue marker. I'm making this up quite randomly. There's an algorithm for that. Different objects have different hashing algorithms, right? Based on guaranteeing the uniqueness of the object based on the value, right? Let's say this is 10, this is 15, this is 25, and this is 30, right? Black is 30, let's say. These hash codes for now, for our understanding, let's assume become index of some kind of an array, which is going to be the backing store for these objects, right? So I say store green marker, I'm going to store that in index 10. Store blue marker, index 15. Store red marker, index 25. Store black marker, index 30. Again, say store another black marker, index 30 is already being used. So, you know, it's ambiguous. It's not going to be, it's going to be ignoring it. So this is how sets are implemented. Remember, I gave you a very, very simplistic layman's analogy. There's much more into it and from the algorithm's perspective, right? But a set, for a set to work, you need to have every object that's being stored as hashable objects. What kind of objects are hashable? We'll talk about that in a while. In a while now, because I can tell you that in summary, I would say that for an object to be hashable, it must be immutable, right? Immutability. We'll talk about that in a while now. Now I talked about sequence and a set. There's also another category of collection called maps. What are maps? Think of maps more like an extension of a set. Technically, in many languages, set is nothing but a map without the value, only keys, right? Only the keys are used. Well, let me tell you what this mapping is. Maps are the Python equivalent of hashes in other languages, associative arrays if you heard about in PHP or TCL, right? Or you could also call them as hash maps in some other languages. Different languages have different terms to represent the same thing. Summary, they are just key value pairs. Hashes generally have, I mean, I'll say it's for the most part, hashes have shared the same property as a set, which is the keys of a hash are unique. Keys of a hash are unique. They used to be unordered, but since Python 3.6, the implementation has changed. They made it a little more efficient. They maintain element ordering now, right? So the implementation is not like having array buckets that you have hash buckets in the set and finding out a slot based on hash code. They use a different algorithm this time. So so hashes, or I will say dictionaries in the maps in Python 3.6 onwards, they are ordered. Okay, they're not really unordered anymore. But having said that, other than that aspect, everything else, they look like a set. For every key, there's a value mapping. So you can consider this way, that you give me these markers and I'm just going to hold these markers somewhere. I'm not going to even show you. I'm going to hold it somewhere. But I remember the markers based on the labels red, blue, green, and black. So if you ask me, give me a black marker, I look up from the internal collection. Oh, what is black? Black is a key. So I look for the key, black, and I find one black marker here. Okay, sorry. I find a black marker here, and I'll give you a black marker. Or you ask me, give me a green marker. I know the label green represents this particular marker. So every marker is now labeled with a key. That's exactly what a mapping is. It's a key value pair. It's a collection of key value pairs where keys are hashable, right? And unique. You cannot have two duplicate keys. you say give me a blue marker, you should be only able to find one blue marker. Only then it makes sense. If there are two blue markers in my hand, now the question is which one, right? So yes, some of you come from C++ background would tell me about multi-maps. Well, you don't have a multi-map in Python. All you have is a real maps where keys are unique. If you want to simulate a multi-map, the values you can represent as heterogeneous type, mostly as a tuple, right? That's how you simulate multi-maps. Anyways, so coming back to the fact about collections, sequences themselves can be further categorized as buffers and references. Just a minute, just hang in there. Yeah. Sequences again are further categorized as sequence buffers and sequence of references. What exactly is sequence buffer and sequence of references? In summary, strings, bytes, and byte array. These three built-in types in Python fall into a category called sequence buffers. Sequence of references, on the other hand, we have tuple and list as two built-in data types that fall into this category. The difference is very simple. Sequence buffers hold data which are contiguous in memory. So I'm going to use a diagram to show you here. Just bear with my very bland diagram skills. Yeah. So consider this as two variables created in the main namespace. I guess you know that every global variable that you create ultimately becomes keys of a module dictionary. Module main has a dictionary, attribute dictionary, and they are stored as keys in the attribute dictionary there, right? Though I say use the word dictionary, it may not really be a dictionary, but it looks like one. It has a key value pair. There are different variations of maps available in Python. So for all practical purpose, when we use the word dictionary, it's a mapping. It's a key value mapping. There are different variations of them, right? So the implementation can be a little optimized for different use cases. Now, this particular dictionary that is there, when I say player is equal to, like say in my Python prompt here, or in this place, if I just say player is equal to John Doe. Okay, we make this code cell. And I'll also say scores is equal to 10, 4.5, 8.9, some random numbers. And I put this inside a list for now. I've created two variables representing two different objects. The first one creates a string, right? There's a string created from the right hand side expression that you see here. There's a little string data. This string object is created in memory, and then the address of the string object is mapped to a variable called player. In this case, when I say scores is equal to a list of numbers in here, like I have an integer and two floating point, a list object is constructed because of the syntax that you have square brackets and you have comma separated elements inside them. This is a literal notation of a string, list, literal notation of a list. So list object is created, and this list lives in some address, and the address is now mapped to scores. So the memory layout of this two variable creation would look pretty much like this. When I say player is equal to John Doe, first a string called John Doe is created in memory. So every single character in the string is contiguous in memory. So if you come from C background, they work pretty much like C character array, right? Just that this is a white string character. That means it's a wchar_t type. The character is not really fixed in length to support Unicode notation for a string. So this is created in memory, but it's memory contiguous, right? If you heard about UTF or Unicode notation, they use that form in here. So whatever address is there, this address is now stored as a pointer inside another structure. This is actually a C structure that's dynamically allocated. We call them as an object in Python world, right? So every object in Python world is ultimately, from the C Python's perspective, is merely a structure dynamically allocated. You can have that kind of a perspective, right? So this string object is created somewhere in memory. The address of this particular string object is stored as a value for the key called player in the main namespace dictionary, the main modules dictionary. So that's what a player is. A player is a variable that refers to a string object holding John Doe. This is a buffer. When I say create a list of numbers, this time 10, 4.5 and 8.9, when I use this semantics like you see here, 10, 4.5, 8.9, first objects representing these numbers are created. An object representing 10, an object representing 4.5, an object representing 8.9. These three objects are independently created. They're all created in different locations of memory. Then ultimately, the reference of all these objects are stored in a dynamically allocated array, also called as a vector. And that vector is what a list represents. And if you see from the diagram, you can see 10 created somewhere in memory, an integer object created somewhere in memory, a floating point object created somewhere else in memory, another floating point object somewhere else in memory. So these addresses, memory addresses, are stored in a dynamically growing array. We call this a vector. This can grow dynamically based on adding new elements, right? And this vector address is represented by this pointer within the list object, which again is a C structure ultimately in the C Python's perspective, which gets dynamically allocated. And the address of this list object is what is stored as a value mapped to the key scores. So what you observe here is that ultimately a list or a tuple, they do not store the values within themselves. When I say list of 10, 4.5, 8.9, these values are not stored within that list. The list ultimately maintains address or references to the objects they hold. That's why it's called as a sequence of references. So some of you might ask me, why did they take this design? Well, actually, you know that list and tuple are heterogeneous. Right now, I use one element as an integer, another two elements are float. But you can do something more. You can actually say, you can actually do this. You can actually say, record is equal to, I could provide 67, then John Doe again here. Then I can actually pass another tuple inside, which contains some values this way. So you can see that a list and a tuple are heterogeneous. The first element of this record is a single value, which is 67. The second element is a string. The third element happens to be a tuple. So you look at the memory layout. An object is created separately for this number 67. A separate object is created for representing John Doe, just like I showed you for a string. And then a separate object is created representing a tuple, which again has references to three different elements. The address of these three objects are what the list internally holds. That's why it's called as a sequence of references. So tuple and list fall into this category, right? Now you might ask me, is there what about string? Why string not sequence of references? We know that strings are homogeneous. Every single item in a string is a character. You cannot have anything else. The character can be a digit, it can be an alphabet, but it's a character, right? So you cannot have anything else. So it's easy to represent a string as a memory contiguous buffer. So if in C Python, it gives you opportunity to use all the C-based optimization. You could use a C character array, a wide character array, and just wrap them with a string object. It gives you that benefit, right? So these are the differences. Now, sets on the other hand, there are two kinds of set: frozen set and a set. Before I go to frozen set and a set, now you can come back and ask me, there's tuple and list. So what is a tuple? Some of you might pronounce it as tuple. I prefer to pronounce it as tuple. Pronunciations vary. Potato, right? Anyway, all right. So a tuple is an immutable sequence. And now I talk about what do you mean by immutable. We use the term immutable. Immutable objects are objects whose values cannot change once constructed. Think of immutable object or immutability pretty much like currency note. If I give you a currency note, right, maybe a rupee note in India, and let's say it's 10 rupees, or maybe if you live in the US in the West, maybe $10. The value of that $10, you cannot change it, right? It's immutable. $10 remains $10. You cannot make that $10 $100 by adding another zero there. It's illegal to do that, and it will not carry that value once you add another zero manually on your own, right? That's what immutability means. The value of it cannot be changed, right? Strings are all immutable. Apart from byte array. Byte array is immutable, but string and bytes both are immutable. In here, we talk about reference sequence of references. We have tuple and list. Tuple is immutable. List is mutable. To demonstrate this, let me just show you. If I create a tuple here, let's say A is equal to 10, 20, 30. It's very easy to create a tuple without a parenthesis. Okay, parenthesis is only to avoid ambiguity. So if there's no ambiguity, you can just have comma separated items. This automatically gets boxed into a tuple in Python. Only when you have something like tuple followed by, if you want to have a tuple of tuple, for example, then you might need to have parenthesis for tuple like this. This is a tuple of tuple. You can see it. Right? It's heterogeneous. There's a nesting. However, if you just go to create simple tuples, you can just have comma separate items like this. This is one of the easiest way to create tuples using the literal notation. Now, once you've created a tuple here and I print it, you can see this. You can access each element of a tuple because it's a sequence. You can actually say print A of 0 or print A of 1. You can access elements based on the subscript or the index, right? This is sometimes called as a subscript operator or the get item operator. Both mean the same thing. Okay, so you're getting an item from a particular collection, and sequences support this feature. Now I can access elements this way. Well, can I modify it? Can I say A of 0 is equal to 100? Can I change it? You cannot. You get this error. You get a runtime error. That is, during execution, you're trying to assign a value to an index of a tuple and it raises a type error. Tuple object does not support item assignment. You can see this line is where the error is. You cannot delete elements. You cannot modify elements. You cannot even append or extend or insert any new elements in a tuple. That's what immutability means, right? A tuple is immutable. Whereas a list, on the contrary, is mutable. To create a list in the literal notation, the easy way to do that is by using square brackets and comma separated items in there. The list is pretty much like a tuple. It has all the properties of a tuple apart from immutability. It's mutable. You can access elements of a list just like you could access elements of a tuple. I'm going to print A. I'm going to print A of 0 and A of 1 this time. You could see that I'm able to access individual items of a list. Can I modify the item? Can I say A of 0 is equal to 100? Can I change it? Well, let's find out. Yes, you can. Think of a list as a mutable equivalent of a tuple. Now, some of you might ask me, what is the use of a tuple? Why do you need a tuple? A list provides more functionality. Why is there a tuple, right? That's a topic for another video. I'm going to talk about the reasons why we have immutable objects, right? So I'll talk about that in another video. But for now, just know that in Python, there are categories of objects which are also called as immutable objects. All numbers are immutable in Python. All numbers, be it integer or floating point or complex numbers, they're all immutable. Strings, by default, str type, string type, the default string type that you find in Python 3, bytes type, they both are immutable. Byte array is a mutable equivalent of bytes, right? If you want to have a mutability, you want to change characters in bytes notation, you could use byte array. I'll talk about string versus bytes in another video again, because that's a bigger topic. I don't want to cover everything in one small overview right now. So there are two ways you can represent string. Raw string, you can say a binary string format, which is called bytes, and the normal textual format, which is string. In summary, if you want to represent raw binary data, use bytes object. If you want to represent textual data subject to Unicode or UTF encoding or maybe internationalization, you go for string objects. It follows the same trend like in most modern languages these days, right? So that's the difference between string and bytes. More details about it I'll cover in the future video. Tuple and list, I told you. Tuple is just immutable, list is mutable, right? Set also has mutable and immutable variant. A set by default is mutable. You can add new elements to a set, you can remove elements from a set, you can do all that. How do you create a set? Well, you could actually create a set basically by, I think s is equal to open curly brace. From Python 3 onwards, you can just create a set using literal notation by using curly braces with just comma separated items. 10, 20, 30, 40, 50, 60. I'm going to repeat these numbers again. 20, 20, 30, 20, 30, 40, 20. The immediate benefit that you see in relation to a set is it guarantees that every item is unique. You can see that right here. But not also that, as I told you, the ordering is lost. When I represented a set, I put 10 as the first element and 20 as second element and 30 as third element and so on. But when I print the set, it shows up 50 as the first element, 20 as second element, 40 as third element. The element ordering is lost. But you can also see that elements are unique in a set. So if you want me to define a set is a unordered collection of unique hashable items. That's what it is in Python. A set is an unordered collection of unique hashable items, right? So that's what set is. Now some of you might ask me what is the use of a set, where do you use a set and where do you use a list. Before I wind up the video, I will just tell you the quick use case for a set. The set is unordered, as I told you, so you cannot subscript it. You cannot say print s of 0. It's not going to work. It is not subscriptable. But however, you can iterate over a set using a good old for loop. You can actually say, you cannot subscript a set, but can I iterate over it? Can I say for value in s, print value? You can use a for loop and iterate over it. Another common misconception about the elements in a set that I've always been asked or confirmed by many participants in the earlier trainings. They ask me whether the elements are randomized. No, the elements are not randomized. These elements are in a predictable location, very predictable location. If you know how to compute a hash of an object, and if you know how to find out the index of a set based on its hash ordering, then you can pretty much know where elements will go in a set. Think of people just walking into a big empty classroom, right? Big empty classroom. The first time when if you're an academic, the first time you walk into a big empty classroom, you will choose a random location in some place. I find that place very comfortable. I go and sit there, right? But eventually what happens, we become very predictable. In a typical classroom, we can almost predict where each person sits, right? In a classroom where we have the same number of students and going through in a full academic year, initially you'll find people just going and sitting at a random location, but eventually you'll find them predictable. Who sits in the last bench, who sits in the last row, who sits in the front row, that. Just giving an example. That's not the realistic feature, but I'm telling you a set. Once you know how the hash is computed and how the hash ordering is decided and how the index is computed, it becomes predictable. It's not random. It's not random, right? So don't assume that a set is a way to scramble data and maintain random order. If you really want to scramble data and maintain randomness, you might want to use random modules, random.shuffle for a list. I think that's better, right? A set only guarantees uniqueness. It's unordered. When I say unordered, Python maintains own internal ordering scheme, not what we expect, right? That's the difference. Clear. If you want to create a dictionary, you can also create a dictionary. As you know, you can say d is equal to open curly brace and say it's a key value pair. Use a similar curly brace like I said, but you have key value pair, right? Key colon value. Some of you might call this as JSON notation. Yeah, Python got it first, right? I mean, this is the kind of syntax that Python had from the 90s, even before the term JSON was coined, I would say. So I'm just keeping it very simple. So I'm just going to show you, this is what a dictionary is. A dictionary also maintains key value pairs where the keys used to be unordered in the early days in Python. Since Python 3.6, they have changed the implementation of a dictionary. By default, dictionaries are ordered now, right? There used to be something called as an ordered dictionary in collections module, which for the large part is deprecated. But wherever you need ordered dictionary, you can just use your normal dictionary in Python. The element ordering is guaranteed, right? All right, this video is going a little longer, so I will be covering every intricate details about these data types in the future videos. The next forthcoming video, I'll be talking about strings in general. I'll tell you about string notations, string operations that you can perform. I'll also talk about list versus tuple and give you some insight when I talk about tuple on immutability, why objects are immutable, why do objects like tuple exists, right, in the future video. All right, so if you really like videos like these, please do comment. I'm not going to tell you about like, subscribe and stuff like that. It's, you know the deal. So if you really find videos like this interesting, I recommend you to just comment and let me know what kind of videos you really want me to do, right? All right, thank you all. Thank you.